Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay guys, this is the 8th part of the series. CSIR Net Physics June November 2020 paper. Okay, so first question I have and these are part C questions which I am solving. The first question I have already solved, and after solving first question my lecture was uh, ended. So the question is a particle with incoming wave vector k after being scattered by potential c upon r square goes out with wave vector k dash. Okay, wave vector k dash. The differential cross section calculated in the first Born approximation depends on. So we need to find out differential cross section, and we need to find how differential cross section is proportional to q, how differential cross section varies with q. Okay, so this is the question guys. So a particle with incoming wave vector k after being scattered by potential, that particle gets scattered by this potential, okay, goes out with wave vector k dash. Okay, the differential cross section calculated in the first Born approximation. Okay, using first Born approximation we have calculated the differential uh, cross section. Okay, and which varies as q, we need to find out. Okay, okay, so relation between differential cross section and q is mod of k minus k dash. Okay, so I'm going to solve it for you. Right. So we know Born approximation formula, right? Okay, using Born approximation for high energy. So f theta, f, which is 2m upon h cut square q. Okay, h cut square q integration. I have already explained the Born approximation in detail in my quantum mechanics lecture, so you can watch that. Okay, so this is 0 to infinity, 0 to infinity. Uh, this is r v r sine qr dr. Okay, this is very important formula, guys. You need to note down. Okay, so this is the scattering amplitude. Okay, this is f, which is function of theta phi, is minus 2m upon h, 2m upon uh, h cut square q integration 0 to infinity r vr sine qr dr. Okay, and here we have been given v is given. Okay, vr is given, since v is given in question, right? V is given, that is c upon r square. Okay, vr is given, vr is given, that is c upon r square. Okay, and now we'll put the value. Simple, right? So this f theta phi is going to be f theta phi is going to be that is, right, we'll write 2m upon h cut square q integration 0 to qr dr. R will get cancelled, and this scattering amplitude is going to be minus 2 mc. C will take outside, okay, minus 2 mc upon h cut square q, into integration minus infinity to, my apology, it's 0 to infinity, 0 to infinity, okay, 0 to infinity, and this is going to be this one. RR will get cancelled, so sine QR upon R dr, sine QR upon R dr, right? This is one. Now these are odd functions, right? So we can break the limit. So this is going to be 2 mc upon h cut square q into 1 by 2 integration minus infinity to plus infinity sine QR upon R dr. We can write this, right? Because we are taking the limit, so we'll this limit we're now just limit, right? This is I told you that you need to note down and memorize it, guys, this value, okay? So very important, and I have also proved it by I have also solved it by Fourier transform, guys. So you can check my Fourier transform lecture and Laplace transform lecture of mathematical physics, which is already completed. So I have already completed mathematical physics in detail and quantum mechanics. B minus 2 mc upon h cut square q into 1 by 2. This value I have already told, right? This is minus infinity to plus infinity sine QR upon R. This value is pi by 2. Okay, very important one. You need to note down and memorize it, guys. Okay, okay. So I'm going to write directly here. Okay, so this is going to be pi by 2. This is f theta phi, scattering amplitude, right? So from here we can find d theta, that is differential coefficient, differential scattering, right? This we know. Right, this is d theta, or we can write d sigma upon d omega, right? This value we know, that is mod square of f theta phi, right? So from here this value is going to be 4 m 4 m square upon h cut to the power 4 q square into pi square upon 16, right? This will be value. So from here we can find d theta. From you can see d theta is proportional to 1 upon q square, right? Theta is proportional to 1 upon q square. That's what is asked in question, right? So calculated the differential. So the differential scattering cross section calculated in the first Born approximation depends on q as. So this is this one. The differential cross section depends on q as like this. So differential cross section is proportional to 1 upon q square, or inversely proportional to q square, right? So which option is matching, guys? Option A. Option A is the correct option, guys. Okay. Well, next question, guys. Question number third. First question I have already explained, right? Okay, so this is second. Now question number third. Question number third is, this is also a good question, guys. A quantum particle a quantum particle a quantum particle a quantum particle in one dimensional in a one dimensional a quantum particle in a one dimensional infinite potential well infinite potential well infinite potential well okay, with boundaries boundaries with boundaries at 0 A is for term sigma delta x minus a by 2. Okay, sigma delta, this is Dirac delta. Okay, x a by 2 to, okay, further by adding this Hamiltonian to the initial initial Hamiltonian to the initial Hamiltonian. The correction to the energies of the ground state, energies of the ground state and the first excited state, first excited state to first order in epsilon are respectively option A 0 and 0, option B 2 epsilon upon A, 2 epsilon upon A and 0, option C is 0 and 2 epsilon upon A, and option D is 2 epsilon upon and 2 epsilon upon A. Okay, this is the question, guys. Very simple question. I'll solve it for you. G's of the correction to the energies of ground and the first excited states. Okay, to first order in ER. Okay, this we need to find. Very simple, right? So I'll solve it for you. So this is going to be this one, guys. Okay, first we'll find, we have been given whatever we have been given, we'll write h dash is given, that is epsilon delta x minus a by 2, right? This is given, and this is infinite potential is given, right? Particle in infinite potential, and boundaries are infinite. This is 0 to A. Okay, and so we know that wave function for this, right? Wave function is psi is root 2 upon A sine n pi x upon A, right? Where n equal to 1 to so on. Okay, this is the value of psi, root 2 upon A sine n pi x upon A, right? So here, right, so now we'll find this one, En1, right? The first order correction in the energy, correction in the energy eigenvalue, En1, right? This we know, that is psi right? So this is going to be, this is the wave function, so this is going to be integration psi star h dash psi d tau, right? So this is going to be En1, this value is going to be energy correction to the first order in the energy, that is going to be this is 1, guys. Okay, this is going to be integration will this is the real wave function, right? So psi star is also the same, so this is going to be root 2 upon a sine n pi x upon a, h dash value is given, uh, that is epsilon delta x minus a in root 2 upon a sine n pi x upon a dx, right? And this is integration 0 to a, because this is the width, right? So en1 is going to be 2 by a, right? And epsilon will take outside, 0 to a, this is going to be sine square n pi x upon a delta x minus a dx, right? We'll use Dirac delta function, guys, right? Dirac delta property here. I have already explained Dirac delta property in detail, Dirac delta function. So this is, I'll show you here. Integration fx delta x minus no. So we'll use this property here. So this is going to be safe, right? So we'll solve it. So this is going to be en1 is going to be sine square a 2 epsilon into 2 epsilon upon a, right? So this is into 2 epsilon upon a. Or we can write and where n equal to 1, 2, 3, because this is a 1D, the particle is 1D, right? 1D infinite potential box. Here n starts with 1, 2, 3, right? And n starts with 1. So this is the energy, the first order energy correction, right? Now we'll find the for ground state n equal to 1. So this is going to be E11, first order correction in ground state. So this is going to be sine square n will be 1, right? Sine square pi by 2 into 2 epsilon upon a, and sine pi by 2 value we know, right? This is 1. So E11 is going to be 2 epsilon upon a. So first order correction to first order correction to the ground state. Now for first excited state, n equal to 2, right? Excited state means for n equal to 2. N equal to 2 means we'll put value. So E21, right? First order correction to the first excited state, right? So this is going to be sine square, this n pi means 2 pi upon 2. 2 pi upon 2 means sine pi, right? Into 2 epsilon upon 8. 2 will get cancelled, sine pi value is 0. So this value is going to be 0. So first order correction in ground state is this, and the first order correction to the first excited state. So which option is matching, guys? Option B is matching, right? Option B. So 2 epsilon upon a and 0, right? So correction, right? Correction to the energies of ground state and excited state, right? So correction to the ground state energy is this, and first excited state is 0. Okay, so option B is the correct option. I hope you have understood it, guys. Okay. Well, next question number 4. Question number 4 is, this is a good question, guys, and yesterday I solved this question in my last lecture of quantum mechanics, that is identical particle. I explained yesterday. That was the lecture, and I have explained this question in detail. Okay, And question again I'm going to explain for you because it's a good question. Okay, and this is question of identical particle, question from identical particle of quantum mechanics. That lecture I have given yesterday, guys, so you can watch that lecture as well. Well, so question is spin half fermions, spin half fermions, spin half fermions of mass, spin half fermions of mass m and 4m in a harmonic potential, in a harmonic potential, in a harmonic potential, in a harmonic potential, Vx equal to 1 by 2 kx square, 1 by 2 kx square. Okay, spin half fermions of mass m and 4m in a harmonic potential this. Okay. which configuration which configuration which configuration which configuration which con four such particles four four such particles four such particles has the lowest has the lowest lowest value of the ground state, lowest value of the ground state, of the ground state energy, ground state energy. Question: four particles of mass m. Option B is four particles of mass 4m, four particles of mass 4m. Option C is one particle of mass m, one, and third particle, three particles of mass 4m, of mass 4m. Okay, and option B is two particles of mass, two particles of mass m and two particles of mass, two particles of mass 4m. Okay, so this is the question, guys. I will read for you. Question, I will explain this question first. Okay, the spin half fermions. Okay, spin half fermions of mass m and 4m. So there are spin half fermions. So one is of mass m and another is of mass 2m. Okay, so spin half fermions of mass m and 4m in a harmonic potential Vx equal to half kx square. Okay, they are in harmonic potential. This is given. Which configuration of four such particles? Okay, which configuration of four such particles has the lowest value of ground state energy? Okay, first combination is given, four particles of mass m. We'll get the ground state energy for four particles of mass m. Second, we'll find the ground state energy of four particles of mass 4m. Then we'll find ground state energy of one particle of mass m, 3 mass 4m. Then we'll find out the ground state energy of two particles of mass m and two particles of mass 4m, right? And then we'll compare, and whichever will be the lowest energy, that will be the answer, guys. Okay, so I'm going to solve it. I have solved this question already in my quantum mechanics lecture of identical particles, explained identical particles. Okay, So we know that we have been given Vx equal to half kx square, half kx square. Okay, this is what we have been given, k is constant. Okay, so this implies particle for particle of mass m, for particle of mass m, Vx is going to be half m omega square x square. Okay, and similarly on, so this is the one, right? So energy is going to be, energy eigenvalue is going to be, energy is going to be, En is going to be n plus half h cut omega, which we have already quantum harmonic oscillator, right, in our quantum mechanics lecture. Okay, second, for particle, for particle of mass, particle of mass 4m, right, Vx is going to be, Vx is going to be 1 by 2 4m omega square x square. In place of m, mass m, will write 4m, right, m omega square x square, right? Or we can write this as 1 upon 1 upon 2 1 upon 2 1 upon 2 m 2 omega whole square, because 4 omega square is 2 omega whole square, right? X square we can write. So from here the energy is going to be, En is going to be n plus half h cut, the energy for particle of mass. Okay, now we'll check option by option. Okay, so first option is for 4 particles of mass m. Okay, for 4 particles of mass m. Okay, 4 particles of mass m. So this is the simple harmonic energy state like this. Okay, this is the energy states, energy levels of simple harmonic oscillator, and the energy is, ground state energy is h cut omega by 2. This is 3 by 2 omega, and so on, right? These are the energy level. So since I have already, my apology, 2s plus 1, so this is going to be uh, plus 1, right? So this is going to be 2, means in one level the maximum particle can stay is 2, right? So 2 particle will be here and 2 particle will be here, right? So the energy is going to be, uh, 1 by this one, for since energy is this we have found, right, n plus half h cut into 2 omega, right? So and for ground state n equal to 0, so this is going to be 0 plus half h cut into 2 omega, right? So this is going to be h cut omega. Similarly En is this, so right, and E1 is going to be 3 h cut omega, and E2 is going to be 5 h cut omega, and so on, right? Because we'll put n equal to 1 for E1, n equal to 2 for E2, and we calculated this is the value. So the energy levels are going to be h cut omega, 2 h cut my apologies, 3 h cut omega, and 5 h cut omega, right? Now you can see and spin is half, right? Spin of particle is half, means only two electrons can stay in one level. Okay, according to Pauli exclusion principle, right? So 2 electron will be here, means 2 particle will be here, 2 particles will be here, right? So energy is going to be, E is going to be, means 2 into h cut omega for this energy level, plus 3 into my apologies, 2 into 2 h cut, my apologies, 3 h cut omega. Okay, 3. So this energy is going to be 8 h cut omega. So for option B, energy is 8 h cut omega. So we have to find the lowest energy level, right? Okay, next is option C. We'll check the energy level. Option C. Option C is guys, this one particle of mass m, three particles of mass 4m. Okay, one particle of mass m and three particles of mass 4m. Okay, so here the now we know the energy level. Okay, energy level for 4m are h cut omega, 3 h cut omega, 5 h cut omega, and for one mass m we know that h cut by 1 by 2 h cut omega, 3 by 2 h cut omega, 5 by 2 h cut omega. Okay, so energy levels for this, right? These are the equal spacing energy. Okay, and we can do like this. This is for this is for 4. These energy levels for 4 uh, 4 h cut omega. Okay, for the mass of 4 particles. So this is the ground state. This is the ground state for this one particle of mass m, right? This is 1 by 2 h cut omega, and this is 3 by 2 h cut omega, right? This is 5 by 2 h cut omega. I can write yeah, h cut omega. And this energy level are for particle of mass 4m. This is the ground state for that. Okay, so this is h cut is uh, 3 h cut omega, this is 5 h cut omega, and so on. These are the ground state energy. These are the ground state energy level for mass of 4m, which I have shown by red ink. Okay, and by blue, these are the ground state energy for the particles. Ground state and the energy levels of particle of mass m. Okay, so now because we know as spin is half, right? So it means in one level only two particles can stay. So it means here you can check. So one particle of mass m is and three particle of mass m. So one particle of mass m is only one, right? So one particle will be here, right? And here this is the ground state. So two particles will be here, okay, and one particle will be here, okay, right? So this is the ground. So energy is going to be very important question, guys. Very important. Energy is going to be for this particle 1 into half h cut omega, plus for this particle, this is the ground state for 4m, right? This is 2 into h cut omega, right? Plus this is 1 into 3 h cut omega. So energy, this is going to be h cut by 2 plus 2 h cut omega plus 3 h cut omega, right? And this energy is going to be 11 h cut omega by 2 means 5.5 h cut omega. Okay, this is this energy. Now option D is, I'll show you. Option D is this one, two particles of mass m and two particles of mass 4m. Okay, for that we'll check. So this is going to be two particles of mass m and two particles of mass 4m. Okay, so again we'll make energy level, right? This one, these are the energy level, and this is for this one. Okay, this is the energy level for this mass 4m. Okay, so this is h cut omega, this is 3 h cut omega, this level is, and this is 5 h cut omega, and so on. And this is for the energy level of 1 by 2 h cut omega, 3 by 2 h cut omega, particle of mass m. Okay, and 5 by 2 h cut omega. So now this particle. There are two particles of mass m, and spin is half means in one level maximum two particle can stay, right? So for this level there are two particles, okay, for this one of particle of mass m, and this is two particles of mass 4m means this is the ground state for this, so there will be two particles. So energy is going to be 2 into half h cut omega plus uh, 2 into h cut omega, right? So this is going to 2 will get cancelled, so h cut omega plus 2 h cut omega, this value is going to be 3 h cut omega. Okay, so this is the answer, h equal to 3 h cut omega, right? Well, so which is the lowest energy? For D, 3 h cut omega, for C, 5.5 h cut omega, for B, 8 h cut omega, and for A, 4 h cut omega. Means option D is the correct option, guys. Okay, 3 point h cut omega is the minimum energy. Okay, okay, so this is the answer, guys. So two particles of mass m and two particles of mass m and two particles of mass 4m has the lowest value of ground state energy. Okay, so option B is the correct option. I hope, guys, you have understood it. Okay, well, next question, guys. Next question, question number 5. Question number 5 is, this is also a good question, guys. Falling drops of rain, falling drops of rain, falling drops of rain, falling drops of rain, drops of rain, falling drops of rain breaks up. Okay, breaks up break up. Okay, falling drops of rain break up and falling drops of rain break up and coalesce, break up and coalesce okay, drop rain break up and coalesce break up and coalesce with each other, with each other, coalesce with each other, and finally and finally finally achieve and and approximately spherical shape, spherical shape, spherical shape in the steady state, in the steady state, in the steady, in the steady state, in the steady state, the radius of such a drop, the radius of such a drop, radius of such a drop scales with scales with scales with the surface scales with the surface tension sigma. Okay, sigma is the surface tension. Okay, sigma as okay. Options are option A 1 upon root sigma, option B root sigma. Sigma is surface tension. Okay, and option C is sigma, and option D is sigma square. Okay, so this is the question. I'll read it for you. So falling drops of rain. Okay, so the falling drops of rain. Okay, uh, rain coalesce. Okay, coalesce means they combine together. Okay, coalesce. Okay, so break up and coalesce with each other. Okay, combine together. Okay, and finally achieve an approximately spherical shape. Okay, and finally they achieve approximately that is spherical shape in the steady state. Okay, the radius surface tensions sigma as. Okay, so how that radius of that drop is is proportional to the sigma, that's we need to find out. Okay, so very simple question, right? This is radius. Okay, radius of such a drop scales with the surface tension sigma as. Okay, so we need to find the proportionally the relation between this radius of drop and surface tension. Okay, how that sigma varies with this radius. Okay, that's we need to find out. Very simple. This you need to note down one formula which is very important. Okay, so work done while combining. Okay, work done while combining. Work done while combining means right. So when they combine these drops coalesces, right, means combine together and form the radius, form a spherical drop, right? Approximately done. Work done. How much work is done, that we are going to find. So how work is done? Work done, that is W equal to, very important formula you need to note down. Okay, sigma, that is surface tension into change area. Change in area. Okay, change in area. Sigma into change in area. Okay, so this is going to be sigma into change in area means 4 pi r square, right? This is the that combined drop, right? Minus n 4 pi r square. These are small drops which combine together. Okay, suppose n number of small drops combine together and form that big sphere of radius r. Okay, so this is very important formula, guys, you need to know. Okay, now very simple. So W is going to be sigma into 4 pi r square, 4 pi r square minus n4 pi r square, right? Now here because r is very small, so taking small r negligible, taking small r negligible, it's a very small. Okay, taking small r, taking small r negligible, negligible, taking small r negligible, that is W. Then if we take the small r negligible, very small, right? So we are just taking as negligible, so it means W is going to be equal to sigma into 4 pi r square, right? Sigma into 4 pi r square. So from here we can find r square equal to W upon 4 sigma, right? So this implies r is proportional to 1 upon root sigma, right? So r is related to sigma like this. Okay, so r is proportional to 1 upon root sigma, or r is uh, inversely proportional to root sigma, right? This is the answer, guys. So which option is matching? Option. So option is the correct option, right, guys? I hope, guys, you have understood it. So, well, guys, before ending the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay, guys, bye now.